Section 6.6, rational equations. If you can do common denominators, then rational equations shouldn't be a problem, and hopefully even if you can't do common denominators, it won't be so bad. So example 1, solve each rational equation if an equation has no solution, so state. So first thing we want to do is make this 5, we need to think of it as 5 over 1, because what we want to do is we want to figure out what the common denominator for all of our denominators would be. We're going to multiply by it, and then things are going to cancel out so we don't have fractions anymore, which is a great situation to have. So, sorry I yawned. Okay, so we have x, 1, and x. Our common denominator, therefore, would be x, or 1x, which is still just x. So what we're going to do is we're going to multiply everything inside of our equation by x over 1. So I'm going to write that out. You can save some steps if you end up being good at this at a later date. So we're going to take 4 over x and times it by x over 1 plus 5 over 1 times x over 1 equals 14 over x times x over 1. Okay, everything gets times by the x over 1. Now, where we already had an x in the bottom, cool things happen because those x's will cancel, leaving us with, for this first term, 4 over 1, which is just 4, 5 times x, which is 5x over 1, so we don't need to put over 1, and then 14 over 1, which is just 14. Now we have a really simple equation to solve. But one thing we have to know is that because of the way we did this, there are values in each case that can't actually be a real solution, and that has to do with where will our denominators equal 0 for what values of x. So in this case, x equals 0. If we put in a 0 where x is, it doesn't work. So if we get 0 for our answer, we would be able to say, oh, well, that's not really an answer. And if it's the only answer, then it would be no solution. So whenever we finish solving this, we just want to keep in mind that it will give us the answer unless it gives us 0, and then we don't really have an answer to this problem. So we subtracted, then we divide. 10 divided by 5 is 2. So we got x equals 2. That's not a problem. We're allowed to plug in 2 here at the bottom. So that means our answer is x equals 2. Now, the rest of these, not any different really, just similar situations basically that we just want to practice through. So we have, for this one, a denominator of 3x, 3, and x. So our common denominator is going to be 3x. So everything here needs to get multiplied by 3x over 1. And again, I am writing out this step where I'm distributing. You wouldn't necessarily have to if you can understand what's going to cancel out. Okay, so what I mean by that is, like on this first fraction, we have 3x in the bottom, 3x in the top, so all of this denominator cancels out and we're just going to have x minus 3. See, that happens right here. We just end up with x minus 3. On this one, the 3 cancels with the 3, leaving us with an x on top to multiply by. So that's what's happening here. The 3's cancel. 4 times x gives us 4x. Then on this last one, the x's cancel, leaving us with a 3 on top to multiply by. So the x's cancel. 5 times 3 is 15, so that's minus 15. Now, we need to solve this equation. Keep in mind that what are we not allowed to plug in? These actually give us the same problem. We're still not allowed to plug in 0. Okay, and so I'm basically just setting the denominator equal to 0. X equals 0 doesn't work. If we set 3x to equal to 0, that's the same thing as x equals 0. So if that's the answer we get, then we don't really have an answer. We would say it was no solution. So I subtract the x over, I'm going to add the 15 this way. That gives us 4x minus x is 3x. Negative 3 plus 15 is 12. So divide by 3 on both sides, and you get x equals 4. Since that's not 0, that's our answer. Now on this one, you can actually think of this a different way, or two different ways basically. One way is our common denominator would have to have x plus 2 and x minus 2. So that's what we're going to multiply by, and that seems maybe really long and annoying, but on the first fraction, we were really just multiplying by x minus 2. On the second one, we're really just multiplying by x plus 2. You can actually think of this as cross multiplication, if you've done that before, because there's a fraction on each side and that's it. If we end up with like something like where it's not just a fraction on each side, we're not allowed to do that. So we would have to continue thinking of it this other way. So on the left side, I really just need to multiply by x minus 2 because the x plus 2's cancel out. On the right side, I really just need to multiply by x plus 2 because the x minus 2's cancel out. I'm going to distribute and solve. Before I do that though, let's think about what values we're not allowed to have. X plus 2 equals 0 means that x cannot equal negative 2. X minus 2, if we said equal to 0, means that x cannot equal positive 2. Those are the two numbers that we want to hopefully not have as an answer. So distribute 4x minus 8 equals 2x plus 4. So we subtract 2x, get 2x, going to add 8, get 12, and that means that x equals 6. So that was not one of our answers, which means that is, like, that wasn't one of our problems up here, so that means that that is the answer. Okay, this one's kind of similar. Our common denominator would be x minus 4 to x minus 7, but this time the x minus 4's will cancel on the left, so we have 3x plus 1, and we need to multiply it by 2x minus 7. What's going to happen is we will need to FOIL. On the right side, the 2x minus 7's cancel out. We would have 6x plus 5 times x minus 4. And then FOIL that out. So two sets of FOILing right here. So 3x times 2x is 6x squared. 3x times negative 7 is negative 21x. 1 times 2x is 2x. 1 times negative 7 is minus 7. 6x times x is 6x squared. Minus 24x. Plus 5x. Minus 20. And at any point here we could think about what values come out up here. Since we have this 2x minus 7, you know, that would be, you'd add the 7 over and divide by 2, so it can't be 7 halves, can't be 4. So we can subtract 6x squared. So our x squareds cancel out. We can go ahead and add like terms here. This is negative 19x minus 7 equals negative 19x minus 20. Oh, if I try to add 19x to both sides, my variables go away. I'm left with an untrue statement, which means that there's no solution. So that's another way we could end up having no solution, is just if it works out like where our variables cancel out like that.